welcome to Trigonometry video 2. In this video we're going to explore non-right angled trigonometry. We'll look at problems involving triangles that do not have right angles. We'll build the rules associated with this topic, so the cosine and the sine rules, and we'll also find some missing angles and sides in triangles and apply the concepts to the area of a triangle, looking at some application problems as well. So let's start with the sine rule, and let's start first of all by labelling a triangle. So this triangle is deliberately not a right angled triangle. A standard labelling will have us give A, B and C, and because they're on the vertices of the triangle, they'll represent our angles. Now what we'll normally do is the capital A will represent the angle, we'll have a little a to represent the opposite side, a little b to represent the opposite side there, and a little c to represent the opposite side there. This is a standard conventional way of representing our triangle, and I'll use this consistently throughout my examples here. So there's my ABC triangle. Now I'm going to show you the sine rule. At this stage, if you're not too worried about the algebraic reasoning why the sine rule exists, you may wish to fast forward now. So first I'm going to drop a vertical line down that forms a right angle with the base of the triangle. I've arbitrarily done that from point C because that's the way my triangle is orientated, but it doesn't really matter which corner I use, and you'll see that I develop a rule that's consistent with all the vertices. So there's my right angled triangle, and I'm going to call the height of this H. So to develop the sine rule, I'm going to start by recognizing that I have two sine rules within right angled triangles. First of all, sine of A is equal to opposite, which is H, over B, the hypotenuse, and this of course leads to H equals B sine of A. And then I also have sine of B is equal to H over A, leading of course to H is equal to A sine of B. So of course if H is equal to B sine of A and H is also equal to A sine of B, then incidentally these two things must be equal. B sine of A must equal A sine of B. And by dividing through by our A and our B value, we get the sine rule. Sine of A over A is equal to sine of B over B. Now, if we were to drop our line that bisected or that created right angles with the base from a different side, so from vertex A or B, we would also get this ratio, sine of C over C. And it holds for all three situations and three options. Or we can have the second sine rule, which is where we have the reciprocal. A over sine A equals B over sine B equals C over sine C. Now, you might be thinking, well, when do I use which one? And the key here really is, if you're looking for a missing angle, well then call that angle sine A and use the first one. If you're looking for a missing side, then call it A and use the second one. Always try and put the thing that you're missing, the thing you're trying to find, as the numerator of one of your fractions. And there we have it, the two versions of the sine rule right here. So let's have a look at a quick example. Here is a triangle, and we've got vertices x, y, and z. Now, until you're really comfortable, you may wish to denote them A, B, and C again, just to help you out. So here is my A, B, and C. First, there's my missing side A, which means that the opposite side is capital A. And here's my other side that I know, which means the opposite angle is capital B. And of course, this leads to an A over sine A, because I'm missing a side, is equal to B over sine B, which gives me x over sine 100 is equal to 5.6 over sine 28. So x is equal to 5.6 over sine 28 times sine 100. And once we evaluate that calculation, we get 11.747. And this of course is in centimeters. So there we have it, the sine rule, why it exists, where it's come from, and of course an example to back that up. Now let's have a look at the cosine rule. So again, I've got a triangle, and I'm going to label this triangle A, B, C, little a, little b, and little c. And here I'm going to derive the cosine rule. So again, if you're not too interested in the derivation, you're welcome to skip forward now until we get to the example and some of the explanations. So first of all, I'm going to drop this vertical line again, makes a right angle, and I'm going to call this H. And from here, I'm going to do some Pythagoras Theorem work. This C, I'm going to split up. I'm going to call this little bit here X, going to the vertical line, which of course means that this bit here is C minus X. So I've got two extra sides there that are going to help me with my two right angle triangles doing Pythagoras Theorem. So I have first of all that B squared is equal to X squared plus H squared, which of course leads to H squared equals B squared minus X squared. And then in the other triangle, I have this. A squared is equal to C minus X squared plus H squared, which of course leads to H squared is equal to A squared minus C minus X squared. And just as before, I can clearly see here that H squared and H squared are equal to two different things, so those two things must be equal, which leads to this. B squared minus X squared is equal to A squared minus C minus X squared there. Now I'm going to go ahead and expand the bracket. Is equal to A squared minus C squared minus 2CX plus X squared. So just make sure that your expansions are appropriate and correct as you're doing them. I'm just going to create a little bit more space here for myself. And then carrying on from there, B squared minus X squared still is equal to A squared minus C squared. Negative of a negative makes it plus 2CX minus X squared. I'm going to add X squared to both sides, which cancels with that and that, leaving me B squared is equal to A squared minus C squared plus 2CX. And now I'm going to note that additionally in the first triangle, we have this. Cos of A is equal to X over B, and I multiply both sides by B, giving me that X is equal to B cos A. And going back to my original function, I have B squared is equal to A squared minus C squared plus 2C times B cos A, which of course is equal to A squared minus C squared plus 2BC cos of A. And now removing the second two terms and putting them onto the other side, I get this. B squared plus C squared minus 2BC cos of A equals A squared, or A squared is equal to B squared plus C squared minus 2BC cos of A. And that's the cosine rule. But this is the first version of the cosine rule. Additionally, with some rearrangement, and I'll leave you to play with the rearrangement, we also have this. Cos of A, so if we have a missing side, is equal to B squared plus C squared minus A squared divided by 2BC. So there's our additional rule, and this one we'll call number 2. So let's have a look at a quick example here. Calculate angle ABC. So angle ABC, of course, is the angle centered at B here. So we'll be using that 10 centimeters as our opposite side, which is the standout value here, the one that's a little bit different to the others, and the included angles work differently. So if I wanted cos A, the little a squared is the negative component. So in this case I want cos of B, which will give me cos B is equal to A squared plus C squared minus B squared over 2AC, which in this case is 8 squared plus 5 squared minus 10 squared over 2 times 8 times 5. And of course this is equal to negative 11 over 80 And so b is equal to cos inverse of negative 11 over 80, and cos inverse of negative 11 over 80 is 97.703 degrees. So there you have it, an answer to a problem that involves the cosine rule. Now, I'm going to cover the area of the triangle in a moment, but before I do that, I'd just like to make a really important note. If you have a non-right angled triangle and you are thinking you may need to use some trigonometry, at this stage you can't use right angled trig, and you also can't use Pythagoras Theorem. Well, have a look at this. All the problems that are cosine rule based involve three sides and one angle. You might be looking for a side, or you might be looking for an angle. Of course, the side has to be the included, so the angle must be the included in between the two known sides there. But three sides and one angle. If I go back to the sine rule, I have two sides and two angles. So we have a 3:1 ratio or a 2:2 ratio, sine to cos. And just have a look at that and use that to help you deciding which rule to use and how to appropriately use that rule if you're working in a problem space. So I'm just going to finish this theoretical component now by talking about the area of a triangle rule. So here's a triangle again, and we'll call this A, B, C, little c, little a, little b there, and we'll also be dropping another vertical line here. At this stage, you may wish to skip forward and just see the rule. So, if I wanted to find the area of this triangle, triangle ABC, so area triangle ABC, well, that would be really quite easy. The area of triangle ABC is equal to a half times the base, which is c, times the height. So the half times base times height. But in this case, we might not know the base. We might not know the height. We know A, B, and C in a lot of triangles, but not the height. So let's imagine instead of the height, we use a different value. Now, let's say we knew this angle here, so we know A. Well, if we were to know A, we could work out the height in terms of A and B, little b that is. So the height will be part of this ratio. Sine of A is equal to h over b, which means, of course, that h is equal to b sine of A. And therefore, the area of triangle ABC is equal to a half c times b sine A, and that, of course, is equal to a half bc sine A, which could be written as half AB sine C, so the most common form, or half AC sine B. Realistically, we could find that triangle with three different methods. But notice here, it's all in naming. So it's just all how you've decided to name it. And usually you'll see this one, where the names A, B, and capital C are applied appropriately. I don't have an example of this, but it's a really simple procedure. So you just need to know that if it's a non-right angled triangle and you don't know the height, but you know two sides and an included angle, and by included angle I mean you know the two sides here and the angle between them, well then you can calculate the area just by following this procedure. That's the area of a triangle.